In this video, we are going to be learning about the division of a line in a given ratio. And of course, we would learn with examples so that we can actually understand what it means and how it's been applied. Find the coordinates of the point which divides internally the line joining the points 8,9 and -7,4 in the ratio 2:3. So what this question is asking is, if we have something like a line and these coordinate points, that is, this is a coordinate point, this is a coordinate point, this is the line joining the coordinate points, and then we want to find out if we are to divide this line into the ratio of 2:3, what is the coordinate point of that part of that line that will divide this line into 2:3. For example, we want to find out just by calculations, instead of like measuring and all those stuff. We want to find by calculation what will be this exact coordinate points. Let's say this is point A, this is point B, and this is point C. So these are the original coordinate points, right? Then we want to find out this. Maybe let's call it point C. And it divides this line into P:Q. But in this question, it's 2:3, right? But we are going to use arbitrary values. So there is no need to go through the rigors of deriving the equation. So it says that the coordinates of the point dividing a line into this ratio P:Q is given by, so the x coordinates will be given by P, right? P, okay, these are the original x1, y1, x2, y2. So these are the original points, that is this point, and then this is the ratio. So the coordinates of the point x, that's for this point, multiplied by x2 plus this other part of the ratio multiplied by x1 over p plus q. That this is what will give us the exact x coordinate for that point. And then for point y, we would have this part of the ratio multiplied by y2 plus the other part of the ratio multiplied by y1 over p plus q. As simple as that. I know it might look overwhelming now, but when we start applying it, you'll see how simple this is to remember. Okay, so and this will give us the coordinates of that point C, x, y. Okay, now we are going to get into this example already. So for this example, the first thing we do is we are going to write out the coordinates. We have 8, 9, and we have -7, 4, and then of course we have its ratio, which is, the ratio is equal to 2:3. So for the purpose of this question, we have that this is x1, y1, x2, y2, and then this is p and this is q. Now let us substitute. So we have that the x coordinate, x will be equal to p represented by 2 multiplied by the x2 plus this other one multiplied by x1 all over p plus q, that is 2 plus 3. And then for the y, we would have p, right? So the first ratio multiplied by y2 plus the second ratio multiplied by y1 over the two ratios added up together. Okay, now let's solve. We'll have 2 times -7 is -14, plus 3 times 8 is 24, over 2 plus 3 is 5. And then for this, we are going to have 2 times 4 is 8, plus 3 times 9 is 27, over 2 plus 3, which is 5. Okay, let's keep solving. Minus 14 plus 24 is giving us 10. Remember, it's divided by 5. And then 8 plus 27 is going to give us 35. 35 over 5. Okay. So 10 divided by 5 is 2. And then we have that 35 divided by 5 is 7. Therefore, the coordinates of the point that you divide that line, original line, right, into the ratio of 2:3 is 2, 7. So this is the coordinates of the point. Did you see it's easy to do? Now in the next example, now remember in this example we are told it divides the line internally. We also have external division. So, but basically it's still the same formula. Then in the next example, we'll see what to do. In the next example, we'll see what to do if it is an external division. It's still the same things. Okay. The point C divides the line AB where the coordinates of P and Q are 3, 2 and 4, 1 respectively in the ratio of 3:2. Find the coordinates of the point C. Now, whenever we look at the ratio and we see a negative value, that means the point we are talking about is an external point. So this is how to recognize external divisions. The previous example we did was internal divisions. Just no problem. Once you see the ratio is positive numbers, just know it's internal division. But when you look at the ratio, we have negative values, then that is an external division. Or sometimes if the question says it divides it externally, so whether you see a negative division, like a negative ratio or not, just know that you have to apply what we will learn now about external divisions. So for external divisions, it's still same formula. But before we go ahead, let us write out our parameters and then label them properly. We have that the first point is 3, 2, the second point is 4, 1, and then our ratio is 3:2. Okay, so we have that this is x1, y1, x2, y2, and then this is point P, and this is ratio P, and then this is ratio Q. Okay, then we now say that the x coordinate for that particular point that divides this line into this ratio is equal to the first ratio, that is P, and then multiplied by the second value for x, P, x2, and then since it's an external division, we have negative instead of positive because of this. So, and then Q, x1 over P minus Q. So all that changes is that there is negative in between this, both for the numerator and denominator. And then for the other one, it is all positives. So internal divisions positive, external divisions are shown by this negative. That's all. And then once we've done that, we will no longer need to recognize this negative here. We'll just put in the absolute value. Okay, we have that this is P y2 minus Q y1 over P minus Q. Okay, so we'll now substitute. We have that x coordinate UB equal to P is represented by 3, x2 is represented by 4, minus 2, x1 is represented by 3 over 3 minus 2. And then we have for y, 3 into y2 minus q is 2, right? Minus 2 y1, 3 minus 2. Okay, we have this as equal to 3 times 4 is 12, minus 2 times 3 is 6, and then 3 minus 2 is 1. On the y side, 3 times 1 is 3, minus 2 times 2 is 4, over 3 minus 2 is 1. Then for the x coordinate is equal to 12 minus 6 is 6 divided by 1 is still 6. For the y coordinates, 3 minus 4 is negative 1 divided by 1 is still negative 1. Therefore, the coordinates of the point C is equal to 6, minus 1, and that's all. And now before we go, let us look at a little tweak in the question. Find the ratio which the point 4, 2 divides the line joining points this and this. So in this question, we've already been given the coordinates of the point which divides the line into a certain ratio, and we've been asked to find what the ratio is. So the first thing we are going to do is we're going to write out the parameters we have. Now let's start with the points, the coordinate points that joins that straight line. So we have 2, minus 4, and we have 8, 14, and then this one is now the coordinates of the points that divides the line into the certain ratio 4, 2. Why I wrote it out here is that so that when we name this one x1, y1, this is x2, y2, then we remember that the coordinates of the points is represented by x and y. So what we've been asked to find is p is to q. That's the coordinates of the points, right? And that's the ratio of the line. Good. Now we are going to write out the formula. By now, I believe we already know how to write out the formula, that the x coordinate is equal to the first ratio p multiplied by the second value of x, right? xp, x2, and from the question, this should be an internal division, because if it's external, it would have been notified that it's an external division. So plus should be here, plus q x1 over p plus q, and then for the y side we have that py2 plus qy1 over p plus q, and then we now substitute. We have that x is equal to 4, p is still p, and then x2 is 8, plus q is still q, x1 is 2, p plus q, and then for the y side, y is 2, y2 is 14, p into 14 plus q into y1 is negative 4, and then p plus q. Okay, we are going to solve equations now. So we multiply both sides by the denominator. We have that 4p plus 4q, right? I jumped that part of having a bracket. I've already spread out the bracket so as to save time. 8p plus 2q. And then on this side, we have 2p plus 2q, right? Multiplying out is equal to 14p minus, because of this, minus 4q. Okay, right now we are going to collect like terms. When we collect like terms, we are going to have, I'll put p on this side because that's the side of the greater p. So we have 4q minus 2q, right? We collected the q's together is equal to 8p is already here, and then minus 4p. So let's finish up with this side. We are going to have 2q, right, is equal to 4p. Now this one is asking us for ratio. At this point, what we are going to do is to have p over q on one side and then know what the numbers are going to be. So to do that, we are going to divide both sides by q. So we now have 2 on this side is equal to p on this side, right, divided by q, so that 4 can go over here. And once we have 2 over 4 is to p over q, that means p over q is equal to 1 over 2. Therefore, that ratio p is to q is equal to 1 is to 2. And on this side, when you finish up this side, you're going to still arrive at the same answer. So that is it for having the coordinates of the points that divides a straight line into certain ratios when given the coordinates of the ends of the line or the coordinates of the line. So I want you to practice, and it will make you perfect the knowledge.